Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 4 video on the chapter of squares and square roots, where I will discuss about how to find the square root of a perfect square number using the prime factorization method. And also I will solve the problems of exercise 3D, which is based on the topic of finding the square root of a perfect square based on prime factorization method. If you have not watched the previous 3 parts on this chapter, then I highly suggest and request that you please watch those videos as well to maintain the continuity of your preparation on the chapter of squares and square roots. So this video is part of the playlist CBSE Maths for Class 8 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my video for the first time or visiting my channel for the first time, I strongly suggest and request that you please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with this video. Okay, so I have my quick notes on the left hand side about the square roots and the prime factorization method for finding square root of a number, and on the right hand side I will do all kinds of discussion and solve the problems of exercise 3D. So let me quickly check if you can see my notes and the canvas. Okay, so first is what is so far we have in the previous videos we have learned about the squaring of a numbers, how to square a numbers, shortcut methods of squaring a numbers using the a plus b whole square, and some patterns in squaring of a numbers, and the column method of squaring a numbers, and the properties of square numbers or a perfect square. Perfect square and square numbers are the same thing. So in this video we will learn about the square root of a number. Now what is a square root of a number? The number x, which is a positive number, a number x is said to be square root of another positive number y if we have x multiplied by x equals to y. So if we have x multiplied by x equals to y, then we say that, or x square is equals to y, then we say that x is a square root of y, and we denote the notation of the square root of a number is if x is so this is the notation of the square root of the number a, and a has to be a positive number. Square root of a negative number is not defined. As you know that square root of a has to be a positive number. So if so we have this is the square root I mean short writing SQ of positive number a. So if there is a number b, if there is another positive number b such that b multiplied by b is equal to a, or b multiplied by b is equal to a square, we know from the laws of exponents. If b square is equal to a, this implies that square root of a, which we denote by this symbol, square root of a will be equal to square root of what is a is b square, b multiplied by b. So this will be b. So this is the basic idea, that the square root of a number a will be another number b such that, and the number b will be unique such that b multiplied by b will give a. Now as an example, so also you can see that if you multiply the square root of a number with the square, if you multiply, you can so these are some very small results. If a be a positive number, so square root of a this is the square root of number a. If I multiply again with the square root of a, then I get a. Then I get a back. So as an examples, you can see the what will be the square root of 4. What will be the square root of 4? We have to see is there any, what is the number for 4? Can we have a number whose square is 4? So we know 4 is 2 multiplied by 2. So hence the square root of 2 multiplied by 2 will be 2. Similarly, square root of 169. So the PDF of my notes, of my quick notes, will be there. The link of the PDF I will provide in the description below, so you can have it check so you can download my quick notes if you think it will be useful to you from the description. So you need not take screenshots from my notes. So square root of 169 is, we know that 169 is 13 multiplied by 13. So square root of 169 will be 13. Okay, so this was the definition of a square root of a number. Now in your class we will fine. So this is the square root of a number. So basic definition of a square root of a number, and that number has to be a positive number, because we do not find the square root of a negative number. That is not, even though that is mathematically possible, it is not in your syllabus, not in class 8. Probably you will learn it in class 11 or 12. Anyway, so we will always deal with the square root of a positive number, and the square root will also be a positive number. That is this square root of a. So this is the square root of a. This will also be a positive number. Will also be a positive number. Now you can argue that if b square, so we are having that if there is a number b such that b into b equals to a, that is b square equals to a, then we are saying b as the square root of a. Let's see, let's consider 2 and minus 2. Now minus 2 whole square we know is 4. So this will imply that square root of 4 is equals to minus 2. Again, 2 whole square we know is also equals to 4. So this should imply, as per the definition we have discussed, square root of 4 is equal to 2. Yes, this is true. This is true that the square root of 4, there are two values, minus 2 and plus 2. In fact, the square root of any number you can consider it has two values. One is positive and one is the negative. But wherever in mathematics we use the term the symbol square root a, we always in general mean the positive value. We mean the positive value. So in your class you will always consider that the square root will be a positive value. So we will write square root of 4, or let's say square root of 9 equals to 3. This is the correct, and square root in your class, at least as of now, this is wrong. We will not write square root of 9 equals to minus 3 as of now in your class. In higher classes you might be dealing with both the positive and negative values of the square root of a number. Okay, so the square root will always be a positive number. Okay, so this was about the square root of a number, positive number. What is its definition? Okay, now let's discuss one method of finding the square root of a perfect square. So given a perfect square, that is a number which is definitely a square of another number. Now if you are asked to find the square root of any number, let's say if you are asked to find the square root of 10, you cannot easily tell. You don't know immediately what is that number whose square is 10. We don't know. Even though this value exists, we don't know. So we cannot immediately say. So in your class as of now, we will always be dealing with whenever we are asked to find the square root of a number, then that number will be a perfect square. That number will be a perfect square. We have to find the square root of a perfect square number or a square number. So in this video, I will discuss about the prime factorization method of finding the square root of a perfect square. Okay. So in the notes, as you can see, let A be a perfect square number. Let A be a perfect square number such that A is can be expressed as x into y, x into x into y into y into z into z into z into z. So x into x into y, all these are its prime factors. So basically, I have find the prime factors of A and I have written down all the prime factors. So now I will rearrange all the prime factors of A such that I will form pairs of factors, pairs of equal factors. So in the next step, so let's say I have a number. So A is a number, A is a given number, and it is a perfect square. We know that it will be a perfect square. So if I do its prime factorization, let's say it is x into is coming out to be x into x, where x is some natural number, x into x, y into y into y into y. Let's say for x and y, where x and y are some natural numbers, and also a is some, let's say, natural number. Now, so I have expressed a as product of its prime factors, and this is the product of its prime factors. Now, from here, I will rearrange the prime factors. I will rearrange the product of the prime factors to form pairs of equal factors like this. X, all the x's, I will take one pair. So this is one pair. I will take another pair where the pair will have equal factors. So this pair has equal factors x and x. This pair has equal factors y and y, and there is another pair left, that is again y and y. Now this next step is from each pair I will take one factor. So x from the first pair, and then y from the second pair, and again y from the third pair. So xy square will be xy square will be equal to square root of a. So the square root of a will be xy square. So how did we arrive to xy square? We rearranged the prime factors of the given number a, and from that product of all the prime factors, we rearranged them to form pairs of equal factors. So this is a pair, this is a pair, and this is another pair. In this example, suppose if the prime factors of a is of the form x into x into y into y into y into z, y into y, and then we are forming the pairs. We are having the pairs, three pairs. First pair is x into x. Each pair will have equal factors. First pair is having the factors x. Second pair is having the factors y. Third pair is also having the factors y. So now we will consider one factor from each pair. We will form the product of factors where each factor is coming from each pair. So we are having x into y. So we are having xy square. So for this example, xy square will be the square root of a. I hope you got the idea. Now a little results as a you can keep in mind, or you should understand. So let's say a, you are given a number a, and let's say you did a prime factorization of a, and it is coming, and you have gathered all the equal factors together. And after doing that, by gathering equal factors together means, let's say I'm taking this example only. Let's say if a is coming out to be x into x into y into y into y into y, so I will rearrange this I will group the same factors with the power. So we have x square multiplied by y to the power 4, y to the power 4. So so any number, any natural number, you can have its prime factorization, and any natural number you can express as the powers of its prime factors. Any natural number, if you do its prime factorization, it will be a product of some powers of the prime factors. So in this case, we are having x square y to multiplied by y to the power 4. So this will imply that square root of a will be you you divide all the powers, you keep the same factors. In this case, the factors are, the prime factors are ax, but it has been raised to power 2. Another prime factor is y, but it has been raised to power 4. You divide all the powers by 2. That is x square, I will divide 2 by 2, multiplied by y, its power is 4, I will divide by 2. So this becomes x to the power 1 multiplied by y to the power 2, that is, this is x y square. So this is exactly, it is written in the notes that if the number a, after you do its prime factorization and after you merge all the same factors with power, if and that is coming out to be something like, let's say, x, where x will be some natural number, x raised to the power m multiplied by so y raised to the power n multiplied by, let's say, z raised to the power p, and let's say u multiplied by u raised to the power q. Now remember, if a is a perfect square, we are only considering the scenarios where a is given, the number a, given number a is a perfect square. So if that is so, all the powers m, n, p, q has to be even number. They has to be even number for a to be a perfect square. You can take it for consideration. M, n, p, q, all these powers of the prime factors will always be an even number. So this is if this is the case, that a after doing so the prime factors of a are x, y, z, and u, and a is expressed as the product of x to the power m and y to the power n, z to the power p, and u to the power q, then the square root of a will be x, you will divide all the powers by 2, x raised to the power m by 2, y raised to the power n by 2, multiplied by z raised to the power p by 2, multiplied by u raised to the power q by 2. As an example, let's say you are asked to find, let's say, what will be the square root of 5 to the power 4 multiplied by 3 square multiplied by 2 to the power 4. Let's say you have a number, you have in a problem you are doing something and you get this expression. So what will be this square root? You have 5 to the power 4 multiplied by 3 square multiplied by 2 to the power 4. What will be the square root? You just divide all the powers by 2. 5 raised to the power 4 by 2 multiplied by 3 raised to the power 2 by 2 multiplied by 2 raised to the power 4 by 2. This is equal to 5 square multiplied by 3 multiplied by 2 square. This is equal to 25 multiplied by 2 multiplied by 3. This is equal to 150. Equal to 150. So this is a little side note or side information or quick results or whatever you can keep in mind as a note. Okay. Now the next two topic I will be is about some typical problems. These are some typical problems. How do we solve this kind of problem? So you will be asked to find the least number to be multiplied with a given number. You will be given a number, a natural number, and you will be asked what by what least number, by what smallest number you should multiply the given number to make it a perfect square. Okay. So it is better I discuss the concept using an example. So let's say, okay, I'm taking an example from the book itself, book of author RS Aggarwal. So let's say it is asked, the number given is 396. The number given is 396, and if you and you are asked by what is the smallest number that you should, what is the smallest number? I am writing it the smallest number to be x. Let's say equals to mm, uh, the given number is 396. So the question is, find x, find smallest x such that 396 multiplied by x is a perfect square. So this is a kind of question, a typical question asked. So you are given a number which is 396, and you will be asked what is the smallest number x that you should multiply with 396 so that the product is a perfect square. So the idea is, you will find the prime factors of the given number. So 396 is the given number. You will find is, if you will do its prime factorization. So let's find the prime factors of the number 396. It divides by 3, 1, 3, 1, 3, 2, and then again it is divided by 3, 43. Is it 43? No, it is 44. It is 44. And then I divide by 2, it is 22. Then again I divide by 2, it is 11. And I divide by 11, it is 1. So we can say that the prime factors of the number 396 is 2 multiplied by 2 multiplied by 3 multiplied by 3 multiplied by 11. So I am following the notes. The step 1 says find the prime factors of A. So we have found the prime factors of A. Now express A as a product of pairs of equal factors from prime factorization. So we have this prime factorization. I will now express these prime factors, product of prime factors, as pairs of equal factors. So this will be the first pair, and this will be the second pair, and we have 11 is left out. 11 is left out. So express A as a product of pairs of equal factors from prime factorization. In this step, some factors may be left out. That is, some factors may not be a part of any pair. So the third step is identify all factors that are not part of any pair formed in step 2. So this was step 1, and this is step 2. In step 2, identify all the factors, all the prime factors which is not part of any pair. So clearly those prime factors are 11 only. 11. So then in the last step, step 4, it says that, I hope you can see my notes properly. Okay. So in the last step says that the product of all factors identified in step 3. So in this example 396, the product, the prime factors which are not part of any pair was only 11. So we have to find product of all factors identified in step 3 is the required least number to be multiplied with A to make it a perfect square. So we have in this example for 396, the only prime factor that is not part of any pair is 11. So this implies x will be equal to 11, because as you can see, 396 multiplied by 11 we will get, since there is one 11, if I multiply it with another 11, 11 into 11 will form a pair. We will have 2 into 2. The prime factorization of the number 396 multiplied by 11 can be perfectly expressed as pairs of equal factors. We will have this. So now we can clearly say that this is equal to 2 square multiplied by 3 square multiplied by 11 square, and from the laws of exponents you know that this will be 2 into 3 into 11 whole square. So clearly we have, so the number 396 multiplied by 11 will be definitely a perfect square. Okay, so this is one. Now in this problem, it is said that we are finding the least number to be multiplied with the given number to make it a perfect square. If the question was finding the least number to be divided with the given number to make it a perfect square, the steps would be exactly the same. As you can see in this number 396, if you multiply with 11, then it is becoming a perfect square. Also, if we eliminate 11, see, if I divide 396 by 11, what is it becoming? So in the prime factorization of 396, we were having the 11 was we were having the 11 as a prime factor. So if I divide 396 by 11, its prime factorization will be like this when expressed as pairs of equal factors. So clearly this is also holds a perfect square, as this is 2 square into 3 square, and this is equal to 2 into 3 square, this is equal to 6 square. So 396 divided by 11 will be 36, which is a perfect square. So the steps, the concept of finding the least number to be multiplied or divided with a given number to make it to make the result a perfect square is the same. For multiplication, you just multiply. You have to identify up to step 3. It is same. Now in step 3, you identified all the prime factors which are not part of any pair, and then you find the product of those prime factors which are not part of any pair. Whatever the value is, that value is the required value that need to be divided or multiplied to the given number to make it a perfect square. Okay, so this was one kind of typical problem that are normally asked. Another kind of typical problem is that you have to find the least square number which is divisible by some given numbers. So you will be given some numbers, some natural numbers, and you will be asked to find the least square number, that is a least perfect square which is divisible by all the given numbers. So as you can, so the steps are, I will explain with an example. Let's again take an example from the book. Let's say the given numbers are, as you can see in the notes, I am referring the given numbers as x, y and z. Now it can be 2 or 3 or 4 or 5, any number of numbers, but at least it will be 2. So let's say the numbers given are x, let's say x is equal to 8. Let's say the numbers given are, we have to find the least square number, a square number, the smallest square number which is divisible by 8, 9 and 10. So what is the least number that is divisible by 8, 9 and 10? That is the LCM of 8, 9 and 10. LCM of 8, 9 and 10 is equal to, what is the LCM of 8, 9 and 10? I have to find out 8, 9 and 10. Just divide by 2, 4, 9, 5, let's say, okay, 8, 9 and 5. So LCM of 8, 9 and 10 is 2 into 4 into 9 into 5. This is 36, this is 360. This is 360. Okay, so 360 is the LCM of 8, 9, 10. Now 360 is the smallest number that is divisible by 8, 9, 8, 9, 10 as LCM stands for least common multiple. Least common multiple, which is a number, which is the smallest number that is divisible by both 8, 9 and 10, which is 360. Now the question is, we have to find the least square number, that is a least number which is also a perfect square. Now the job is to, how can we from 360, how can we convert it to a number which is a perfect square by multiplying it with a smallest number. If we have from 360, if we have to get the nearest number which is a perfect square, then the question the question boils down to the fact that what will be the least number which we need to multiply with 360 so that the result will be a perfect square. Now please keep in mind, you cannot find the least number that need to be divided with 360 to get a perfect square, because if you find the least number if you find the least number that need to be divided with 360 to get a perfect square, whatever that perfect square will be, that will not be divisible by 8, 9 and 10, because if the concept is that you have to find the least square number which is divisible by 8, 9 and 10. We have found the LCM 360. Now definitely, if you divide 360 divide by some x, if you divide some x by number some x where x is definitely greater than 1, this number is not divisible by all of 8, 9 and 10. If you divide the number 360 is the LCM of 8, 9 and 10. That is the least number which is divisible by 8, 9 and 10. And the moment you divide 360 by some number, natural number greater than 1, that number will no longer be the LCM of 8, 9 and 10. That is, that number will not be divisible by all the numbers 8, 9 and 10. So you cannot divide from 360, you cannot divide by some number to get a perfect square. You have to multiply with some number to get a perfect square. So in this problem, now after getting the LCM, we have to find the least number that we need to multiply with 360 so that the result is a perfect square. So now the question has boiled down to the previous typical problem, which was finding the least number to be multiplied with a given number to make it a perfect square. So for this example, so we have 360. What we need, the question now is by what number we should multiply 360 to make it, what least number we should multiply 360 to make the product a perfect square. So we have to find the prime factorization of 360. So let's do the prime factorization of 360. Let's divide by 2. This is 180. Then again divide by 2. This is 90. Divide by 2. This is 90. Again divide by 2. This is 45. And 3. This is 15. And 3. This is 5. So the prime factorization of the number 360 is 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 3 multiplied by 5. Now I will rearrange the prime factors to form pairs of equal factors. Now I can see there are 3 2's, so I can form one pair. 1 2 will be left behind, and I have there are 2 3's, I can form one pair, and I can see 1 5 is left behind. So now the least number, least x, so that 360 multiplied by x is a perfect square, is a perfect square will be equal to, we have to find from the prime factorization. After we have arranged it in pairs of equal factors, we have to identify all those prime factors which are not part of any pair. Those factors in this problem 360 are 2 and 5. So this will be 2 multiplied by 5 equals to 10. So this implies 360 multiplied by 10 equals to 3600 is the least square number divisible by the given numbers, divisible by 8, 9, 9, 9 and 10. Let me quickly check if I did it correctly or not, because I am prone to make mistakes. Okay, it is fine. So 3600 will be the least square number divisible by 8, 9 and 10. I hope you got the idea. Now let's solve. So this is all about the concepts of the square roots and finding the square root of a given perfect square using the prime factorization method, and two typical problems. Let's now solve the problems of exercise 3D. Let me bring up the question paper, problems of exercise 3D. I hope you can see. Okay. Okay, let's solve the problems of exercise 3D. So this exercise 3D is based on finding the square root of a given perfect square number using prime factorization method, and some application of the prime factorization methods. Okay. Find the square root of each of the following numbers by using the method of prime factorization. Okay, so there are many, there are 11, there are how many? 12 numbers. I will not be doing all of them, I will do few of them. So 2, 2 to 5. So basically we have to first do the prime factorization. So let's find the prime factors of the number 2 to 5. Let's divide by 3. We have 73, not 73 but 75, and then let's divide by 5. We have 15, and then again by 5 we have 3. So 2 to 5 is, we can see the prime factors are 3 multiplied by 5 multiplied by 5 multiplied by 3. These are the prime factors. Now I will arrange the prime factors so that I get pairs of equal factors. So this becomes 3 multiplied by 3, this is one pair, and the another pair is 5 multiplied by 5. So this will imply that the square root of 2 to 5 will be, I will from the prime factorization expressed in the form of pairs of equal factors, I will take one factor from each pair. So this is 3 multiplied by 5, this is equal to 15. So 15 is the square root of 2 to 5. Okay, let's do 2. 441. So let's find what is the prime factorization of 441. 441. Now, what is the divisor of 441? 3. 3. Yes, it divides with 3. 1, 4, 7. Okay, and then it again divides with 3, 4 and 9, and we have 7 and 7. So clearly we see 441, its prime factorization is 3 into 3. We can directly pair the equal factors, 7 into 7. So this implies square root of 441 will be equal to, we will take one equal factor from each pair. So 3 into 7, this is equal to 21. So the another way of doing it to find, I mean, you have to do the prime factorization. You have to do the prime factorization, but instead of forming the pairs, instead of forming the pairs of equal factors, you can directly express the given factors. Let's say I have this prime factorization, and if I express it as the powers of the different prime factors, this will become 3 square multiplied. This is 3 square multiplied by 7 square. And I said, so this is 3 square multiplied, so we have 441. This is another way you can also do it. So so you do the prime factorization of the given number, and since it is a perfect square, you will see that the prime factorization, if you merge all the similar factors with their powers, all the powers will be even. So you, for this 441, we have 3 square into 7 square. This will imply that the square root of 441 will be equal to all the powers of the prime factors. I will divide by 2. So this becomes 3 multiplied by 7, which is 21. Okay. Let's do 9. Let's do 9. We have 9, 2, 1, 6. First, let's find out what is the prime factorization. This is the major step for finding the square root using prime factorization method. Now, what will be what? Okay, let's first divide by 2. We have 4608. Okay. Then again divide by 2. We have 2304. Then again I will divide by 2. I have 1152. Then again, if I divide by 2, I have 576. Then again, if I divide by 2, I will have 288. Then again, if I divide by 2, I have 144. It is going very long. Okay. Then 72. Then 36. Oh God. Then 18. Then 2, 9. Okay. We can leave 9, but anyway, let's do it. 3 into 3. Okay. So we see 9216 is 9216. How many 2's is there? How many 2's is there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We see 2 to the power 10. Why? It will be 2 multiplied by 2. 2 multiplied by 2 10 times. So we have 2 to the power 10. And then we have 3 square. So I'm doing it in a little different way. But anyway, the common step is that you have to find the prime factorization. You have to find all the prime factors. Now, instead of dividing by 2, you could have also divided by 4 or 16. You could have also done that. But for the sake of simplicity, I have divided by 2. So I've tried with 2, 3. I will try for prime factorization. I always try to divide with the prime numbers from the smallest to larger number. So 2, 3, 2, 3, 5, 7, 11 like this. 5, 7, 11 like this. Okay. So we see that 9216 is equal to 2 to the power 10 multiplied by 3 square. So now I can directly say that square root of 9216 will be equal to, I will divide all the powers by 2. So it becomes 2 raised to the power 10 by 2 and 3 raised to the power 2 by 1. So this is 2 to the power 4, 2 to the power 5 and 3. Now 2 to the power 5 is 32 multiplied by 3, which is 96. I don't know whether this is correct or not. Let me quickly check in the calculator. 96 multiplied by 96 is 9216. Okay. Okay. Now I did this problem a little differently, but anyway, the common step is to find the all the prime factors. So I found all the prime factors, and then I expressed the prime factorization as the product of powers of individual prime factors. So in this case, 9216, the two prime factors were 2 and 3, and the entire prime factorization can be raised as powers of 2 and 3, and then the square root will be, I will divide the powers of the individual prime factors by 2, and that will be the result as the square root. Now from you could have also, I mean, the concept is same. You could have also create a pair of equal factors. So this could be first pair, this could be second pair, this could be third pair, this could be fourth pair, this fifth pair, and we have 3 into 3. So definitely from the first pair I will select one factor, one equal factor, another equal factor, another equal factor, another equal factor, another equal factor, and the last factor 3. So the result will be same. The concept is same. Okay. Let's do problem. Let's do find the 10. That is the square root of 11025. Now first let's find out, do the prime factorization, and you can I will use the powers of prime factors, that method. So let's first find all the prime factors of 11025. Let's divide by 5. So 2, 2, 0 and 5. Then again I will divide by 5. I have 4, 4, 1. Okay, so we got 441, and we already know that what is 441. 441 is 3 square multiplied by 7 square from problem number 2. I will take that help. I will not do it again. But if you want, okay, no problem. Let's do it. I will divide by 3. This is the 1, 4, 7. I will divide by 3. This is 49. And then I will divide by 7. So we can see 11025, its prime factorization is 5 multiplied by 5. From the prime factorization, I am doing it using the powers of the prime factors method. That is, I will see how many 5 are there from the prime factorization. There are 2 5s. So it will be 5 square multiplied by how many 3s are there? 2. So 3 square, and there are 2 7s. So I can say that 11025 will be 5 square multiplied by 3 square multiplied by 7 square. So this implies square root of 11025 will be equal to, I will divide all the powers of the prime factors by 2. By 2. So this becomes 5 multiplied by 3 multiplied by 7. This is equal to 15 multiplied by 7, which is equal to 105. 105. Okay. So is 105 the correct answer? Let me quickly check it using the calculator. Yes, it is 11025. Okay. Let's do problem number 12. I'm not doing any other problems for finding the square root using prime factorization method. I'm doing 12. The main task is doing the prime factorization, and then I hope it's quite easy. So 17424. Okay, let's do the prime factorization of 174 and 24. Let's divide by 2. We have 8, 7, 1, 2. Let's again divide by 2. We have 4, 3, 5, 6. Let's again divide by 2. It will be a long division, long computation. Okay. let's divide by, will it divide by, let me try to shorten the calculation by dividing with 4. So this is 1 0 8 9, I guess, and then let's divide this by 3. We have 3 6 3. Then again divide by 3. We have 1 2 1, and this we know is 11 11. Okay, so we see that the prime factors are, how many 2's are there? There are 2 2's, so 2 square, and we have 4, and we have 2 3's, 3 square, and we have 2 11 11 square. Now we have 4. We know that 2 square, 4 can be written as 2 square. We have 3 square multiplied by 11 square. Now if you merge 2 square multiplied by 2 square, we get 4 square. Now this method, it might look a little different from the usual method of using prime factorization to find the square root given in the textbook, but it is fine. You can do it this way. But anyway, the main task is to find the prime factorization of the given number. Now we have this. Now, so therefore we can say, so you can see, even though 4 is not a prime factor, is not a prime number, but it is fine. The result will come correctly. So now we can say that the square root of 1742 will be equal to, I will divide all the powers by 2. So I have 4 multiplied by 3 raised to the power 2 divided by 2, and 11 raised to the power 2 divided by 2, and I get 4 multiplied by 3 multiplied by 11, that is 33 multiplied by 4, which is equal to 132. So let me check if this is correct or not. 132 multiplied by 132 is 17424. Okay, so I will not do the rest of the problems of finding the square root. I hope you got the idea and you can do the rest. Let's do problem number 13. So these are kind of what problems. Problem number 13 says, find the smallest number by which 252 must be multiplied to get a perfect square. Also, find the square root of the perfect square so obtained. Okay, so we have to find the list number. Let's say that be x, so that this is a perfect square. Is a perfect square. That is, find x, find list x, find list x such that 252 multiplied by x is a perfect square. So what we have to do, the essential step is to do the prime factorization of the number 252. So divide by 2, we have 26, and then divide by 2, we have 63, and then we divide by 3, we have 21, 3, we have 7. Okay. So the prime factorization of 252 is 2 multiplied by 2 multiplied by 3 multiplied by 3 multiplied by 7. So the next step is we will rearrange the prime factors as a product of pairs of equal factors. So this is can be the first pair, 3 multiplied by 3 is another second pair, and 7 is left behind. 7 is left behind. So the least number, so this is the required number. So this implies we can say that x is equal to 7. Now x will be 7. That is the from after we have rearranged the product of the prime factors as product of pairs of equal factors. From that we will obtain all the prime factors which are not part of any pair. So in this example, 7 is the prime factor which is not part of any pair. For some other number, there could be multiple such prime factors which are not part of any pair, and we have to find the product of all those prime factors which are not part of any pair. In this problem, it is only 7. So 7 is the required least number that need to be multiplied with 252 so that the result will be a perfect square. Now let's see what is 252 multiplied by 7. This will nothing, we have already done the prime factorization of 252. So if we multiply 7, multiply 252 with 7, it becomes 2 multiplied by 2. We already have this 3 into 3, and since there was only one 7 and we are multiplying it with another 7, it will form a pair. So this will imply that so this is okay. So now we have 252 multiplied by 7 is this. So this is 2 square multiplied by 3 square multiplied by 7 square, and from the laws of exponents we can say that this is equal to 2 into 3 into 7 whole square, which is equal to 42 whole square. So the question was, find the smallest number by which 252 must be multiplied to get a perfect square, which is 7 in this problem. Also find the square root of the perfect square so obtained. So the number obtained after multiplying with the least number, that is 7, is 252 multiplied by 7. So this implies that the square root of the new number obtained by multiplying the least number with the given number was 252 multiplied by 7. So its square root will definitely be 42. So this is the answer of the second part, and this is the answer of the first part. The least number to be multiplied is 7, and the square root of the new number obtained after we multiply 7 with the given number is 42. Okay. Let's do problem number 14. Find the smallest number by which 2925 must be divided to obtain a perfect square. So in this time we have to find the number that must be divided, not multiplied, divided. Also find the square root of the perfect square so obtained. Okay. So what is the question? Find least x such that 2925 divided by x is a perfect square. We have to find x. Now let's do the prime factorization of 2925. 2925. We have to find the prime factorization of 2925. Okay. Let's divide by 5. We get 5, 8 and 5. Okay. Then again divide by 5. We get 1, 1 and 7. And then divide by 3. We get 39. And then divide by 3 again. We get 13. And we have 13. Okay, so the prime factorization of 2925 will be 5 multiplied by 5 multiplied by 3 multiplied by 3 multiplied by 13. Now, if I express these prime factors as a group of, as a pairs of equal factors, I get, if I form the pairs, this will be one pair, this will be another pair, and 13 will be left behind. So 13 is the number by which we should divide 2925 to get a perfect square. So x is equal to 13. Therefore, 2925 divided by 13, what is the new number? When we divide the given number by 13, 13 is the least number that need to be divided, by which the given number should be divided to make it a perfect square. Now, if I divide 2925 by 13, we get 5 multiplied by 5 multiplied by 3 multiplied by 3, because in the prime factorization of 2925 it was seen that the prime factor 13 was left alone. So if I divide 2925 by 13, it will become 5 into 5 multiplied by 3 into 3. This is nothing but 5 square multiplied by 3 square, and this is equal to 15 square. 15 square. So this implies the new number that is formed by dividing the given number by the least number, the square root of that number is, we can see, is 15. So definitely the second answer is, the second part, the answer to the second part of this problem is 15, and the first part is 13. That is, the given number 2925 must be divided by the least, 13 is the least number by which 2925 must be divided to give a perfect square, and that perfect square is the square of 15. Okay, let's do problem number 15. One, 2 to 5 plants are to be planted in a garden in such a way that each row contains as many plants as the number of rows. Find the number of rows and the number of plants in each row. Okay, so there are total 1, 2 to 5 plants to be planted in a garden in such a way that each row contains as many plants as there are number of rows. So if there are, let's say, okay, let there be x rows. There be x rows. This implies each row has x trees. Each row has x trees. This implies x rows will have definitely x multiplied by x trees. So this implies total number of trees, total number of trees is equal to x multiplied by x, which is x square. Now we have to, what we have to find? We have to find find the number of rows, that is x, and the number of plants in each row, which will be same. So we have to find essentially x. X is the number of rows. We have assumed that there are, we have assumed that there are x rows. So if there are x rows, then definitely each row, as per the problem, each row is having x trees. So x rows will have x into x trees. So therefore the total number of trees is x square. This implies it is given that the total number of trees is 1, 2 to 5. So from here we can see that x will be equal to square root of 1, 2 to 5. Now we have to find the square root of 1, 2 to 5. Let's use prime factorization method. I will divide. Let's find the prime factorization of 1225. So we now have to just find the square root of 1225 using the prime factorization method. So 2, 4, 5, and again divide by 5, 4, 9, and 7 and 7. So this is equal to, we can see, square root of 1225 is, we can see, 5 into 5 multiplied by 7 into 7, and its square root will be definitely 5 into 7, that is 35. So 35 is the answer to both the question, that is 35 is the number of rows, and 35 is also the number of trees in each row. Okay, let's do problem number 16. The students of a class arranged a picnic. Each student contributed as many rupees as the number of students in the class. If the total contribution is 1156, find the strength of the class, that is the number of students. Okay, so the idea, the basic concept is the same as the problem number 15. So let there are x number of students. So this implies x students. No, let there be x number of students, and it is given that each student contributed as many rupees as the number of students in the class. So this implies each student contributed rupees x. So this implies x students contributed rupees x multiplied by x. Using the unitary method, we can say that if one student contributed rupees x, then x students contributed rupees x into x, that is rupees x square. This implies it is given that the total contribution in the class of the total contribution was rupees 1156. So we can say that rupees x square is equal to rupees 1156. This implies x square is equal to 1156. This implies x is equal to root over 1156. So every word problem is boiling down to the fact of finding the square root of some number. So we have to find the square root of 1156 using the prime factorization method, and let us first find the prime factors of 1156. Let's divide by 2. Let's divide by, to keep the simplification shorter, to keep the calculation shorter, let's divide by 4. 4. So I have 2, 8 and 9, and then this will again divide by 7. This is 4 and no, not 7. 289. 7. No. 3. No. 13. No. 289. What is the 289? I think it's 17. 17, I think. Let's quickly check. 119 and 117. Yes, 289. Okay, so so the prime factors of 1156 is 4, 17 and 17. So we can write square root of 1156. 1156 we can replace it with its prime factors, that is 4 multiplied by 7 multiplied by 7. This is equal to 2 multiplied by 2 uh, multiplied by 17 and using the method of finding the square root using prime factorization method, we can say that the square root will be, we will take one equal factor from each pair. So it is 2 multiplied by 17, that is 34. So 30x is 34, and what was x? X was the total number of students in the class. So that is what the question has asked. The question has asked find the strength of the class, that is the number of students, which is x, which is 34 in this problem. So answer is 34. Okay, let's do problem number 17. Find the least square number which is exactly divisible by each of the numbers 6, 9, 15 and 20. Okay, so we have already discussed about in the theory how to find the least square number which is divisible by some given numbers. So the given numbers are 6, 9, 15 and 20. So first we have to find the LCM of these given numbers. LCM of 6, 9, 15 and 20. Let's find out the LCM of 6, 9, 15 and 20. Let's divide by 3, let's say 2, 3, 5, 20. Let's divide by 2, 1, 3, 5, 10. Let's divide by 5, 1, 3, 1, 2. Okay, so the LCM will be 3 multiplied by 2 multiplied by 5 multiplied by 3 multiplied by 2 is the LCM, which is equal to okay, so this is the LCM. Fine, I will not find the product of, I will not find the value of this, of the product of the I will not, it is not necessary to find the actual value of this product. Let it be in the product form, in the product of its product of the prime factors. So we now know that the least number, so we have found the LCM, which is the least number which is divisible by, say, the given numbers, that is 6, 9, 15 and 20. So whatever the least, so the LCM we have found in terms of product of prime factors. Now we have to make that a square by multiplying with the least number. So we see that this is the, if we see the prime factors of the LCM, it is, if we group the prime factors in pairs of equal factors, we can see 2 pairs and 1 5 is left behind. So whatever the LCM we have found the LCM of 6, 9, 15 and 20 in terms of the product of prime factors, and that product of prime factors, we are arranging the prime factors in pairs of equal factors, and we got 2 pairs, that is 3 into 3 and 2 into 2, and we see another prime factor 5 is left behind. So therefore this implies the least square required means the least square number that will be divisible by 6, 9, 15 and 20 will be equal to, we have to multiply this number, that is the LCM, by 5. If you multiply this with another 5, we get whatever that value is, we can express it as pairs of equal factors, where each factor is a prime factor. So this is 3. This is, we can say, 9 multiplied by 4 multiplied by 25. So we have to find the least square. Okay. So this is equal to 9 multiplied by 100. So this is equal to 900. So 900 is the least square number that is divisible by the given numbers 6, 9, 15 and 20. So what was the procedure? From the given numbers we found the LCM. Now it is not required to find the LCM as a single number. It will not help that much. You keep the LCM in the form of product of prime factors. So in this example, we see the LCM is coming out to be the product of 3. It is 3 multiplied by 2 multiplied by 5 multiplied by 3 multiplied by 2. And now from this LCM, whatever this LCM will be, we have to multiply with it with the least number to make it a perfect square, and that least number will be all the prime factors in the LCM that are left behind, that are not part of any pair. So from the prime factors of the LCM, we will rearrange the prime factors of the LCM to make pairs of equal factors. And if we see whatever and all the prime factors which are not part of any pair, the product of those prime factors will be the least number that we should multiply the LCM, so that the product will be the required least square number. And so we get in this example the only prime, the number that the least number that we need to multiply the LCM is coming out to be 5, as 5 is the only prime factor which is not part of any pair in the prime factorization of the LCM. So we multiplied by 5 and we formed another pair 5 into 5, and hence the required least square number is the LCM multiplied by 5, which is 900. Okay, let's do problem number 18, which is the last problem. Hope you can see the problem number. Okay. The problem number 18 says find the least square number which is exactly divisible by each of the numbers 8, 12, 15 and 20. What? Oh, it is same problem just like 17, but the given numbers are a little different. Find the least square number which is exactly divisible by. Okay, so this time the numbers are 8, 12, 15 and 20. Okay, so let's find what is the LCM of the given numbers. The given numbers are 8, 12, 15 and 20. So let's find the LCM of 8, 12, 15 and 20. Let's divide by 5 and I get 8, 12, 3 and 4. Let's divide by 2. We get 4, 6, 3, 2. Let's divide again by 2. We get 2 minus 3 minus 3 minus 1. Okay. So LCM, the LCM will be 5 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 3. I am keeping it as a product of prime factors because it will help me in forming the pairs of equal factors. So we have LCM this. Now let's express the prime factorization of the LCM as pairs of equal factors. So I get there are 3 2's, so one pair can be formed and I am left with 1 2, and I see 1 5 is left, and another pair can be formed from 3 2's, from 2 3's. Okay, so I see the prime factors which are left, which are not part of the any pair, is 2 and 5. 2 and 5. So this implies the least required. You can say that now it is okay. So required least square number will be equal to the LCM, that is the LCM, the bottom LCM of 8 to 15 20 uh, multiplied by the product of all the prime factors that are not part of any pair. So which in this problem is 2 into 5. So now we get this is equal to 2 multiplied by 2. We have 2 this was the LCM. This was the LCM, and we are multiplying it with 2 multiplied by 5. So this is what 2 into 2 is 4, and we have 4. So this is 4, and we have 3 into 3 is 9, and we have 2 into 5 square, which is equal to 4 into 9 into 10 square, which is equal to 4, which is equal to 36 multiplied by 100, which is equal to 3600. So 3600 is the least square number which is divisible by the given numbers 8, 12, 15 and 20. So this brings to an end of solving the problems of most of the problems from exercise 3D, which is based on finding the square root of a perfect square using the prime factorization method, and some typical problems which is based on the prime factorization method, that is the least number to be multiplied to a given number, the least number to be divided and multiplied with the given number to make it a perfect square, and also to find the least square number which is divisible by some given numbers. So I hope this video was beneficial to you. If it is, then please like it, share it with your friends, and once again please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. The next topic of this chapter will be to find the square root of a perfect square using the long division method. And in that video we will also solve the problems from exercise 3E, and then we will proceed with finding square roots of numbers in decimal form and fractions. So please stay tuned for the next video, where I will discuss about finding the square root of a perfect number using long division method and solve the problems of exercise 3E. So thanks for watching, and until the next video, take care and bye.